Hello everyone, welcome to Science Solutions with Karishma. This is the part 4 of the chapter Rational and Irrational Numbers of Class 9 from the Concise Mathematics of Selina. And in this video, we are going to solve from question number 5 to question number 12 of exercise 1b. So this is the question number 5. Use the method of contradiction. Contradiction means opposite or denying any fact. We have to show that root 3 and root 5 are irrational by contradiction. So let root 3 and root 5 are a rational number. We have to take the opposite thing. Since we have to prove they are irrational, so let's take it as rational. So root 3 may be written as a by b because it is rational. So a and b are the integers where b is not equal to 0. In the same way, root 5 can also be written in the form of x by y, where x and y may be any integers and y is not equals to 0. So here we got root 3 equals to a by b. When we cross multiply it, we get b into root 3 equals to a. So we have to square the both sides. Squaring both sides will get b into root 3 whole square. B into root 3 whole square equals to a square. So b square root 3 square is 3 into 3 equals to a square, or 3b square equals to a square. So let us take it as equation 1. So from this equation, we can take out the value of b or b square. B square equals to a square by 3. So we got the equation 1 here. From here, we can find the value of b or b square. B square equals to a square upon 3. Here we found that a square is divisible by 3. So we may write it as it implies that a square is divisible by 3. So therefore, a is also divisible by 3. Since a square is divisible, so a is also divisible by 3. So we'll write it here, equation 2. So a is divisible by 3. This is equation 2. Next, we have to assume that the value of a is any number. That number we'll take by looking at the divisible number. That is, it is divisible by 3, so we'll take 3m. So putting this value in equation 1, putting a is equals to 3m in equation 1, we'll get 3b square equals to 3m whole square. Since equation 1 is 3b square equals to a square, a means 3m, so we got the value 3b square equals to 3m whole square, or 3b square equals to 9m square, or 3b square, we'll take 9 in the left hand side, it will be divided, so m square. So 3 1s are 3, 3 3s are 9. So we'll get the value b square upon 3 equals to m square. So again, we got that b square is also divisible by 3. Look here, b is divisible by 3, or b square is also divisible by 3. So you'll write here, since b square is divisible by 3, that means b is also divisible by 3. So this is equation 3. So as you can see that from equation 2 and 3, we got that a and b both are divisible by 3. So we'll write here from equation 1 and 2. From equation 1 and 2, we got that a and b both are divisible by 3. That means both A and B have a common factor, that is 3. So we can write it here as, since a rational number does not have any common factor except 1, we know that the rational number doesn't have any other common factor except 1. So we'll write it as, from equation 1 and 2, we get A and B have a common factor 3. But in the rational number, there should not be a common factor except 1. So this contradicts our statement, that is, it is contradiction. Therefore, this contradicts. Therefore, this contradicts our assumption that A by B is rational, since it has 3 common. So A by B is not a rational number, but it is an irrational number. We'll write it like this. Hence, root 3 is also irrational number. So in this way, you have to prove by the method of contradiction that the number is irrational. First, we have to see by which number it is getting divided, and then we'll assume the same number. We'll take the value of A as the same, and by contradiction, we'll find the value. And for root 5, we'll follow the same method to find the answer. So that is your homework. I think you can do it. So the next question in exercise 1B is 6. Prove that each of the following number is irrational. So here we have to prove by contradiction method. So question number 1 is root 3 plus root 2. This number we have to prove that it is a rational number. So we'll assume let root 3 plus root 2 equals to x, and x is a rational number. Since we have to prove it is irrational, so we'll take the opposite, that it is a rational number. So now to remove the root, we'll square the both sides. By squaring, we get root 3 plus root 2 whole square equals to x square. Now, when we square, add, subtract, or multiply or square anything, the number will not change. That is, it will remain rational only. So x squared is also rational. So here we got the formula a plus b whole square. So by applying this formula, here a is root 3, b is root 2. So a square plus b square is root 3 square plus root 2 square plus 2 into root 3 into root 2, 2ab equals to x square. So root 3 square is 3, root 2 square is 2, plus we'll multiply the number outside the root, that is 2 1s are 2, 2 1s are 2. So 2, 3 into 2 is 6, root 6 equals to x square. 3 plus 2 is 5 plus 2 root 6 equals to x square. Now we have to give only the root 6 on the left hand side. So for that we'll move plus 5 to the right hand side. So we'll get 2 root 6 equals to x square. Since it is plus, it will become minus 5. So again we'll give only root 6. This 2 will be divided. So x square minus 5 upon 2. Since it is multiplied, it will get divided. So we'll get this value. Now we have to prove that this value is rational. Because previously we have taken x as a rational. So if x is rational, then the whole thing is rational. So we'll write, since x is rational number, that means x square minus 5 is also rational. So from here we got to know that if x square minus 5 is rational, root 6 is also rational. So it implies that root 6 is also rational. So you know that root 6 is not rational. It means that it is contradicting our statement. So it contradicts our statement that root 6 is rational, since it is irrational. So we'll write, this is contradiction. This is contradiction because root 6 is irrational number. So from here we got that if root 6 is irrational, therefore x square minus 5 upon 2 is also irrational. So we got the answer that root 3 plus root 2 is also irrational. So that's how you prove your answer, by the method of contradiction. Let's have a look again how you prove that it is irrational. So first we took the whole number as a rational, taking x as a rational number and squaring both sides. We remove the roots, and by solving we got the value of root 6. If x is rational, then the whole thing is also rational, but root 6 is irrational, so it contradicts our statement. So by the method of contradiction, we prove that x square minus 5 upon 2 is also irrational. That means root 3 plus root 2 is also an irrational number. Moving on to the next question, that is question number 2 of question number 6. That is 3 minus root 2. We have to prove this number is irrational. So in the same way, like we have done in the previous sum, question number 1, we will prove that this number is irrational. So we have to assume that 3 minus root 2 is a rational number. Suppose x is a rational number. Now, we have to keep only the root in one side and the numbers in one side. So root 2 will move on to the right hand side. Since it is negative, it will become positive, and we'll take x on the left hand side. So it will be 3 minus x equals to root 2. Now, since x is rational, as we have taken x as a rational number, since x is rational, then 3 minus x is also rational number. But 3 minus x equals to root 2, and root 2 is an irrational number. So we can say that this is contradiction. This is contradiction. Why? Because root 2 is irrational and we cannot say that 3 minus x is rational. So this is contradiction because root 2 is an irrational number. Now we'll write as, therefore 3 minus x is also an irrational number. This means that x is also irrational. Therefore, 3 minus root 2 is also an irrational number. This is how you prove your answer by the method of contradiction. Next, we have question number 3, that is root 3 minus 2. In the same way, we have to assume that root 3 minus 2 is anything like x, a, anything. It is a rational number, and the same process will follow and will prove the answer. So the next question is question number 7. Write a pair of irrational numbers whose sum is irrational. Here we have to take two irrational numbers. They may be non-terminating, non-recurring decimals, or the number which are inside the root which cannot come outside of it. For example, if in square root, if a number is inside a square root, it should have a pair of 2. For example, in square root, if there are two 2's, that means it has a pair of 2, so it will come outside. In cube root, if there are three 2's, that means it has a pair of 3, so it will come outside. They will become rational. But those numbers which cannot come outside the root, they are irrational. For example, root 2. So we may take any number. Here we are going to take in pairs 2 plus root 5 and 2 plus root 5 again. Or we can also take 3 plus root 5. You can take any number. Here I am taking 2 plus root 5 and 3 plus root 5. And then we'll have to find the sum. Sum means addition. In case of finding irrational number from irrational number, we'll take the same sign, positive sign. So let the two irrational numbers be 2 plus root 5 and 3 plus root 5. In both the case, we are taking plus plus to find the irrational. So their sum will be 2 plus root 5 plus 3 plus root 5. Here we'll get 2 plus root 5 plus will not change the sign, so 3 plus root 5 again. Now we have to add the numbers first. 2 plus 3 is 5, and there are two root 5's here. We got 5 plus 1 root 5 and 1 root 5. That means 2 root 5's. 1 plus 1 is 2. So we'll get 2 root 5. Now here you can see that there is still a number inside the root, that is root 5. That means it is irrational. So we had to find this irrational number. So this is your answer. You need to keep in mind one thing in this type of question. If it is asked to find the irrational number from the pair of irrational number, then we'll take the same positive sign. We cannot take one positive and one negative. Let's see if we'll take 2 plus root 5 and 2 minus root 5. Since there is a minus sign there, so it will cancel out the root. When you add it, you get 2 plus root 5 plus 3 minus root 5. So here you've got plus and minus, then it will cancel out the root. Then you'll get the answer 5. That is rational, not irrational. So we should not take the two opposite signs, but we have to take the same sign, either plus or minus minus. In the similar method, in the similar way, we are going to solve the next question, question number 8. Write a pair of irrational numbers whose sum is rational. Rational numbers means the numbers which can be positive, negative, or any integers including 0. So we have to take a pair of irrationals. So let us take 3 plus root 7 and 3 minus root 7. Here we have to take the opposite sign. When we are finding rational from irrational numbers, we are taking opposite. So here we get 3 plus root 7 plus 3 minus root 7. Here we got minus root 7 plus root 7. Cancel out. You'll get 3 plus 3, 6. So we got the answer in rational. So from irrational, we got the rational number. Question number 9, we have to find the difference of the two irrational numbers, and the answer should be irrational. Difference means subtraction. So we will take the opposite sign here, plus and minus. So let us take 3 plus root 7 and 3 minus root 7, plus and minus. So here we have to find the difference. Difference means subtraction, minus. So 3 plus root 7, minus will change the sign, minus into minus plus root 7. So here we got plus root 3 and minus root 3. Here you got 1 plus 1 is 2, root 7. So yes, we got the answer in irrational. Next question is question number 10. Write a pair of irrational numbers whose difference is rational. So from irrational we have to find a rational by the difference, means by subtracting those numbers. So difference means subtraction. We are going to take the two same sign. Since we are finding the difference, so minus will change the sign, so it will become difficult to find the rational number. So we are taking the same sign, that is the positive sign. So let's take any number like 2 plus root 3 and 2 plus root 3. You can take the same number, or you can take any other number. Suppose we take it as 3. So you have to find the difference. That means you have to subtract 2 plus root 3. Now minus will change the sign. Minus into plus, minus, minus into plus, minus. So here we'll get 2 plus root 3 minus 3 plus into minus, minus root 3. Here we got the opposite sign, plus and minus, so it will cancel out. Then we'll have 2 minus 3 is minus 1. That is a rational number. The next question is, write a pair of irrational numbers whose product is irrational. Product means multiply. So here we have to find irrational number from irrational number. For that, we'll have to keep the root. So that's why we'll take the different number inside the root. If we'll take the same number, it will be square and the square will cancel the root. So let's take root 3 and root 5. You can take any other number and find their product. So we have here root 3 into root 5. Multiply 3 and 5, we'll have 15. So yes, 15 cannot come outside the root. That means it is an irrational number. So we'll have to take the different numbers for that. Next question is question number 12. Write a pair of irrational numbers whose product is rational. So here we have to find the rational number by the product of two irrational numbers. So here we don't need the root. So we have to square it, since square will cancel the root. Here we have to take the same number, or we have to take the positive and the negative numbers. So let us take 3 minus root 2 and 3 plus root 2 as the two irrational numbers, and we'll have the product of them. So product means multiply. So here we got a minus b into a plus b formula, that is a square minus b square. So here a is 3. So 3 square minus b is 2, root 2. So root 2 whole square. So we'll get 9 minus, square will cancel the root and we'll have 9 minus 2, 7, and that is a rational number. So that was all in this video. In the next video, we are going to solve the questions from question number 13 to question number 20, the last question of exercise 1B. Till then, keep watching and don't forget to subscribe to my channel.